Everyone, and once again we are back together, right? I hope that you are well, and today we'll be discussing the IEB November 2019 exam paper. So please, if you haven't subscribed, do the right thing and let's get right into it. Okay, we start with section A. They say to us we've got negative 2 is one of the roots of the equation, 2x squared plus x plus k, right? We need to prove that k is equals to negative 6. I think this is quite straightforward, right? So in this case, we're just simply going to substitute in there, right? So we're going to say we've got, okay, this thing is refusing to write. Okay, so we've got 2 times negative 2 squared plus x is negative 2 plus k equal to 0. And this gives us 8, right? Minus 2 plus k equal to 0. I'm sure you can see that k will be negative 6. Right, so they say determine the other root. So which means we need to actually factorize this, right? So 2x squared plus x minus 6 is equal to 0. Now we already know that minus 2 is a root, isn't it? So that means that one of the brackets will be x plus 2, right? So what will be the other one? So in this case, it should be 2x. And of course, you can see how that will be negative 3, right? So that's if we factorize it. So we've got x is equal to negative 2. Of course, that's the one that we got before that we're given. But the other one is x is 3 over 2, right? So this is the other root. Okay, right. And then they say to us we need to solve for x in each case. Right, so we're going to solve for all of them. Right, so this is definitely a case where we are squaring both sides, right? So I'm going to take the x to the other side. So I've got minus 3 root x plus 2, which will be equal to 2 minus x. Right, if you want to, you can multiply both sides by negative. So this will be 3 root x plus 2, which will be equal to x minus 2. Right, so what I'm going to do is I'm going to square both sides. Okay, so what do I have? I'll have 9 into x plus 2. Right, remember once you square, in this case, you square the 3, so it's 3 squared, and it's the square root squared, which removes the square root. And in this case, we're going to have on the other side x squared minus 4x plus 4. Right, so let's try and solve as quickly as we can. So that's x squared. Right, on this side, you've got 9x plus 18. Right, so this is x squared minus 4x plus 4. And how are we going to solve this? We're going to have x squared. Right, if you take the 9x to the other side, it becomes negative. So this becomes minus 13x. All right, and we've got 18. Right, if we take it to the other side, 4 minus 18 will give us negative 14. All right, so this is equal to 0. This is quite easy to factorize, right? Factors of 14 such that when you minus them, you get 13. That's definitely going to be 14 and 1, isn't it? So this is going to be, our 14 is going to be negative actually. All right, so that's negative and that is positive. That's equal to 0. So x is equal to 14 or x is equal to negative 1. Now, please remember, ladies and gents, you need to always go back to your equation to check if any of these solutions do not actually qualify, right? So let's take this one, 14, right? So I'm going to substitute it here on the left-hand side and the right-hand side. And what do you get? I get negative 3 is square root of 14 plus 2, which is 16, right? And on the right-hand side, I've got 2 minus a negative 14. Now notice this, square root of 14 plus 2, this is square root of 16, right, which is 4. So this is minus 3 times 4. Okay, that's minus 12. And on the other side, what do I have? 2 minus a positive 14, right? And in this case, in fact, no, I actually made an error. This was positive 14, not negative. So that's 2 minus 14, right? That's 2 minus 14. Okay, so what do I get there? I get negative 12. So it looks like 14 is a right answer because I've got a negative on the left as well as on the right hand side. So this answer would definitely be correct. Right, now I'm going to substitute 1 there, and negative 1 that is. So this is going to be square root. Okay, let me just remove the entire thing. So this is going to be minus 3 square root of minus 1 plus 2. And on the right hand side, I've got 2 minus a negative 1. Okay, so I've got negative 3. Now notice under the square root, in this case, I've got root of 1, so that would be minus 3. And in this case, I've got 3 minus minus 1, that gives me positive 3. So definitely no ways that you can have negative and positive on the other side. So this one would not be applicable. I hope that makes sense, ladies and gents. Right, let's go on ahead to the next one. So they say to us, we've got x squared minus x less than or equal to 6. So what we need to do is just find our critical values. So x squared minus x minus 6 is less than or equal to 0. Right, so what are those critical values? Right, it's going to be, let's factorize. So that's x minus 3 and x plus 2. So we've got minus 3 and 2. So now what we go and do is to go and plot those critical values, right? So we've got negative 2. Remember, it changes sign, as well as 3. And this represents a parabola, right? So I want you to think about it. That parabola is positive here. It's negative between negative 2 and 3. And it becomes positive again. So now, where is this parabola less than or equal to 0? I'm sure you guys can see that this will be the solution. So, which means, in this case, when I find the solution, x will be an element of, now please note, I will include the values because they said less than or equal to. So x is an element of negative 2 all the way up until 3, which is also included. Otherwise, you can put it this way: x is less than or equal to 3 and greater or equal to negative 2. All right, I hope that makes sense. Right, now we will go on to question 2, right? So now they show us the balance that is owing on a credit card. They say Busi opens a credit card amount that charges a compound interest of 12.3% per annum, compounded weekly, right? So they say for the calculation in this question, assume that the relevant years have 52 weeks each. Right, now they say to us, she purchases a computer for an amount of 12,349 immediately after activating her credit card, right? Now they say to us, show that the balance owing on the credit card 1 week after the purchase will be 12,378. Now, please note in this case, this is definitely going to be compound interest. So we're going to say the accumulated amount is equal to the principal amount 1 plus I, right, to the exponent n. So we know that the computer costs 12,349, right? And this is 1 plus. Now note in this case that we are compounding an interest of 12.3%, right? So we need to divide that by 100, okay? But this is on a weekly basis, right? That's 52 weeks. So in this case, what we're simply going to do is to say 0.123. Now remember, this is 12.3 divided by 100 divided by 52, right? But now, how many weeks is this? They said after 1 week. So n would be equal to 1, right? So let's do that quickly. So this is going to give us 12,349, right, into 1 plus, okay, 0.123 over 52. Okay, and all of that to the exponent 1. We don't need to write anything there. And I'm sure you can see that final answer. That's 12,378, okay, and 21 cents. All right, and that's exactly what they said we needed to show. Right, now let's go on to the next one. They say determine how long it will take Busi to pay off the money that she owes on her balance, on a credit card, if she repays an amount of 94 Rand and 75 cents, right? And she does not make any other purchase on this credit card. Now, all right, now ladies and gents, remember, in this case, we're looking at the accumulated amount, right, that will be made from that 94 Rand and 75 cents, right? So we're looking at the future value, right? So in this case, I want you to note this is how much that she pays, right? This is definitely looking at the amount of money that she owes, right? So we're going to say, right, so we know that the future, or rather the present value is, okay, actually let's write down the formula. Present value is equal to x, right, into, we've got 1 minus 1 plus I minus n, all of this over I. All right, so our present value is 12,349. Okay, we are paying an amount of 94 Rand and 75 cents. Okay, so please be very careful when you substitute here. This is 1 plus. Now note I is 0.123, but this is over 52, right? And we want to know the number of months. Okay, remember that our n in this case will represent months. Okay, this is going to be 0.12, or if you want to, you could have said 52n, right? So that you know that if you want the number of years, you're going to actually multiply or divide by 52. So this is 0.123 divided by 52, right? Actually, this is just for that part. So, right. Now, ladies and gents, I know a lot of you, when it comes to this section, you tend to, be afraid, very afraid, right? Because of the calculation. So I am just simply going to do this in the calculator. I'm going to divide by 94.75, right? And I'm going to multiply by that number there, right? So let's take that. So that's 349, right? Okay, let me first multiply by 0.123 over 52. Okay, and in this case divided by 94.75. Okay, please note it's just a lot of calculator work that is involved here. Right, so this is divided by 94.75. Okay, and I'm going to now subtract that 1 there. So that's minus the 1. Okay, I get a value of minus 0.691 ... right? I'm not going to remove that answer, So this is equal to negative 0. No, actually, this is equal to negative. Now remember, I'm left with this on the bracket, so that's 1 plus 0.123 over 52, right, minus n. Now, what do we do at this stage, ladies and gents? First of all, I'm going to multiply both sides by negative, right? So that gets rid of those negatives there. And what are we going to do? Introduce logarithms, right? So I'm going to introduce logs. So log of that, right? Now, what happens when I introduce a log? Okay, so I'm going to have, in this case, remember the rule of log says I can jump down. So minus n into the log of that entire expression, 0.123 divided by 52 is equal to the log of what I have in my calculator. I'm not going to remove anything so that we do not lose any solution, right? So I'm going to say this is multiplied by negative 1, okay? No ways, I just made an error there. Okay. Yeah, there's my answer. Okay, so I should say answer times negative 1. Okay, I get that. Right, so I'm going to say the log of my answer, right, divided by, so I'm going to divide both sides by the log of that entire thing, right, of 1 plus 0.123 over 52. Right, so divided by the log of 1 plus, okay, again, sorry, that's the fraction, 1 plus my fraction, that's 0.123 over 52. Okay, right. And what is my final answer, ladies and gents? I get a final answer of 156. So n is equal to negative 156. Now that's because I just wrote a lot of things here, okay, which were really unnecessary. All right, so let me just make some space. So I got a value of n is equal to 156. Now notice, this is in terms of weeks, right? Okay. If you had said this is 52 times n, which is the number of years, so if we want the number of years, so this would be 52n would be 156, and so to get n would just simply divide by 52. Okay, and I get an answer of 3. Okay, so this would take 3 years for her to pay off that credit card. All right, I hope you understand that. Okay, so the next portion, they say to us, if the depreciation rate of her computer is 20% per annum on a straight line basis, determine what its value will be after 2 years. So remember, when it comes to depreciation, okay, so all we simply do, this is on a straight line basis, so this is the same as simple interest. So this is going to be P 1 plus I times N, right? Okay, so the accumulated amount or the depreciated amount, this is 12,349, right? 1 plus. Now remember, the interest component is 0.123, right? In this case, over, no, actually, this is just this is 0.2, sorry about that, 0.2, that's not the interest of the credit card, but we're given the interest per annum there. So this is 0.2 multiplied by, remember, we want to know after 2 years, so this would be, n would be 2. Okay, so let's do that quickly. So that's 12,349 into 1 plus 0.2 times 2. And we get, okay, what happened there? Sorry, that's supposed to be minus because that's depreciation. Okay, right. Sorry about those many errors. Okay, so that's minus. And so that gives us, now, of course, that was my way of diagnosing that we didn't get the incorrect answer, because remember, with depreciation, something is supposed to actually lose value, right, with time. So that's 7,409 cents and 709 and 40 cents, right? Okay, so this is what the computer is worth after 2 years, right? And now they say she wants to sell the computer after 2 years, right? Will the depreciated value of the computer be sufficient to pay off the outstanding balance immediately after 104th payment? Show all working. Right, now 104th payment would be after 2 years, right? So that's 52 weeks times 2, right? So now we want to calculate the balance. Let's find out what the balance on this loan is, right? So what I'm going to do is I'm going to say, right, to get the balance, this would be, please, I want you guys to stay with me. So this would be the amount that, this person took, right? So 12,349, that's the amount of, or that's what the computer is worth. But now to get the amount that she owes, right, it would be what has accumulated from the 12,400 with compound interest on a weekly basis, right, minus, but remember, what is she doing? She's servicing the debt and she's paying an amount, right? But in the amount that she's paying, in this case, it accumulates to a particular value over time. So what are we going to look at? It will be minus the future value of this actual amount that she's paying on a monthly basis. So I'm going to say, right, so in this case, it's the accumulated amount minus the future value. So the accumulated amount in this case, this will be P into 1 plus I exponent n minus, now remember the future value formula, that's x into, that's going to be 1 plus I exponent n minus 1, okay, all over I. Okay, so let's try and do that. And we'll talk about this n just now. So in this case, that's 12,349, 1 plus. Now remember the interest, 0.123 over 52. But this is after 2 years, ladies and gents. So how many months is that? So that will be 104 months, right? So we want to know after she's actually been paying for 104 months. So now how much is she paying? She's paying 94 rands and 75 cents. So 94 rands and 75 cents, right? Oof, I just placed myself into a corner there. So 0.123 over 52, right? Please note there, to the exponent n, which is 104 minus 1, okay, divided by, this is 0.123 over 52. Right, so that's a lot of calculator work we're going to have to do. So that's 12,349 into 1 plus, okay, that's 0.123 over 52. And in this case, we've got 104. Sorry, that's exponent 104. Okay, that's minus. All right, we should be very careful when we're using these calculators, right? This is minus an amount of 94 rand and 75 cents, but in this case accumulated. In fact, let's do this so that I make sure that I maintain a level of accuracy, right? So that's minus 94.75. I'm going to open two brackets there. That's 1 plus another fraction, 0.123 over 52. All right, let's close that bracket there. Yx 104. Okay, and let's close that entire bracket over there. All right, and then this is divided. Oh no, actually I was supposed to say minus 1 thereafter, right? So let's remove this and say minus 1. Okay, and close that bracket. Okay, I think we're good. And then this is divided by another fraction again, 0.123 over 52. All right, and what do we get for our final answer? I get an amount of 4,631 and 56, or well, let's say 57 cents. Right, so that's the balance that I get. All right, if he pays this amount on a monthly basis, right? So in this case, which means this will be the amount that he will be owing. But now think about it. We said that in this case, the value of the computer, if he sells it, definitely he should actually be able to cover this amount. All right, I hope that makes sense, ladies and gents. Now, what I wanted to also do is to show you just another method in which we could get the balance. But in this case, because it wasn't a balance or rather an accumulated amount that was stipulated by the bank, let's see if it actually works, whether we'll be able to get the same answer. Right, so you can also get the balance, right, by using the present value. Yeah, and that's the correct word. By using the present value of the amounts that are still outstanding that he is still to pay in the months that are still outstanding. Now remember, you are supposed to pay for 3 years, but now on the second year, this is when we want to find out the balance. So how many months are still outstanding? It's 52 weeks actually. It's 12 months, but it's 52 weeks that are still outstanding. So let's find out what is, in this case, the present value if we use that. So I'm going to say, well, it's x into, so that's 1 minus 1 plus I minus n over I, right? So I'm going to try and see if that gives us exactly the same answer. So that's 94.75, okay? And now, okay, let's do this. That's 1 minus 1 plus 0.123 over 52, right? Exponent minus 52, because those are the months that are outstanding, right? So this is divided by 0.123 over 52. Now let's check and see if we'll be able to get to the same answer. So that's 94.75, okay? and I'll say 1 minus, open that bracket, 1 plus 0.1, rather, that's 0.123 over 52, right? And we close that bracket, that's yx negative 52. Okay, let's close that bracket. Okay, and all of this, right, so this is equal to, that's divided by 0.123 divided by 52. Okay, I get, well, approximately the same value. Do you see that? So that's 4,630, well, you can say 30 and 89 cents, right? So definitely that tells us that we are actually quite correct. So this is the balance that he will still be owing. But remember, in this case, so we can say, therefore, it means that he will be able to cover, they said to us, will the depreciation value of the computer be sufficient? Okay, so let's say the depreciation value will definitely be sufficient. Okay, he'll actually sell this at a profit. Okay, so the depreciation value will be sufficient. Okay, right, I hope that you understood that, ladies and gents. Really, these things are quite tedious, but, well, we are done. That's 16 marks in the bag as we go to the next question. All right, question 3 starts with calculus. They say to us, determine f dash x from first principles. Now remember, how do we find f prime x? So f prime x will always be limit as h tends to 0, right, of f of x plus h minus f of x, right? All of this divided by h, right? Now, please remember, you do not drop this until you substitute 0 for h, right? So which means I'm going to take my equation, right? So that's minus 5. Everywhere where there's x, I'm going to put x plus h. So this is h plus x squared plus x plus h, right? Minus, now please remember to put this in brackets, minus 5x squared plus x. Okay, and this will be divided by h. Okay, so I'm going to say equal to limit as h tends to 0. Right, now let's deal with what's in the bracket, right? So this is going to give us x squared plus 2xh plus h squared, okay, plus x plus h plus, now note, negative times a negative is a positive, so this is going to be plus 5x squared minus x, and this divided by h. All right, so this is limit as h tends to 0. Okay, now if we multiply that entire thing, we've got minus 5x squared minus 10xh minus 5h squared, right, plus x plus h plus 5x squared minus x. Now, ladies and gents, I'm not going to waste time here, right? Find the ones that are similar. Of course, this is all divided by h. Okay, I'm gonna have to also try to save some space here. Right, so 5x squared minus 5x squared, those cancel out, right? The plus x here, the minus x cancel out. Okay, and what am I left with? Right, I can now take out h as a common factor, right? So in this case, I'm left with 10xh, right? And in this case, if I take h out as a common factor, so limit as h tends to 0, so h, that's minus 10x, right, minus 5h, all right, plus 1, okay? All of this divided by h. Now notice we can cancel that one out. And what are we now left with? We can now substitute 0 for h, right? So I'll be left with minus 10x, right? Minus 5 times 0. Okay, plus 1. Oops, I am really out of space there. And so this will be minus 10x plus 1. And that is how the cookie crumbles. All right, and to go to the next one, they say hence or otherwise determine the equation of the tangent of f of x at the point where x is equal to 1. So remember, in this case, the equation of the tangent, that's f prime x, we've just established that this is going to be minus 10x plus 1, right? So at x is equal to 1, so we're going to say this is f of 1, f prime at 1. So that's minus 10 times 1 plus 1, right? Okay, so this will give us minus 10 plus 1, which will give us minus 9. Now remember, they said to us we need to determine the equation of the tangent, right? So now where are we going to get, so which means the equation of the tangent will be y is equal to minus x plus c. But how do we determine the c value? So we were meant in this case to find out what are the points. So I'm going to find f of 1, right? Right, so it's minus 5x squared plus x. So that's minus 5 times 1 squared plus 1. Okay, so I substitute 1 for x. So this will give us minus 5. That will give us minus 4. So which means the point that the tangent passes through is 1 and minus 4. Okay, so I'm going to substitute that point there. So that's negative 4 for y when x is 1, and get the c value. So in this case, I've got minus 9. If I take it to the other side, it becomes positive. So c will be equal to 5. So the equation of our tangent will be equal to minus 9x plus 5. I hope that makes sense, ladies and gents. Right, as we swiftly move on, right? So we are trying to find the derivative. But remember, for you to find the derivative here, you need to first try and simplify, get rid of all the surds, get rid of all the the denominators, x at the denominator. So we're going to say this is x3 over x plus, rather. Now remember, this is going to be x. Now remember, in this case, a surd will give us 3, but this is now divided by 2, okay? Right, so in this case, divided by x again. So y is equal to, right, so the law of exponents, so that's 3 minus 1. So we've got x squared there, plus, so we've got a 1 as well there. So that's 3 over 2 minus 1. So that's plus x is 1 over 2. So 3 over 2 minus 1 gives us 1 over 2. Now we can get dy over dx, right? What does it give us? Jump down, so this is going to be 2x, right? Plus 1 over 2 x minus 1 over 2. And so this will give us 2x plus 1 over 2 root of x. So if you take the minus 1 over 2, this is x to the power positive 1 over 2, right? And what does this become? That's 2x plus 1 over, so that's 1 over 2 root of x. And that is what the derivative works out to. Right, again, they want us to find the derivative with respect to x. Let's go on to the next one. So they say to us, we're trying to find the derivative with respect to x of that expression. Right, now, I want you to note this entire thing that is inside this bracket is raised to the exponent minus 1. So what does that mean? I'm going to rewrite this. So that means the top part becomes 8x cubed minus 27, right? And this part now comes to the denominator for x squared plus 6x plus 9. All right, so what I'm going to do is let's try to factorize this top part, okay? Now, if you look at it, you can already tell that if you took 2x, which is the cube, kind of a cube root of, that top expression, the cube root of 8 is 2, the cube root of x cubed is x, the cube root of 27 is 3, right? So, which means this must be one of my factors. So, I'm trying to create 8x cubed minus 27. And this is equal to 2x minus 3, right? Now, what are we going to do? 2x multiplied by what will give me 8x cubed, right? For those of you who've watched me do calculus, you've seen me use this method, right? Then we go to the last term, 27, right? 3, okay, just want to use a different color. 3 multiplied by what will give me negative 27. And you can see that that will give us positive 9. Okay, right. Now, to factorize it further, we're going to say, right, so I don't have an x squared term. So if I take 3 multiplied by 4x squared, that gives me 12x squared. And if I say this is plus bx, so if I take 2x multiplied by bx, that will give me 2bx squared. And this will simply give me 0x squared because I don't have an x squared term, right? So that means, right, if I drop my x squared in this case, so that's 12 plus 2b will be equal to 0. So 2b, this was supposed to be minus 12x squared. So that's negative 3 times 4x squared, right? So that's minus 12 plus 2b. So 2b is equal to 12, and therefore b is equal to 6. So you can see that this will be 6x, right? So which means if I take that expression that's at the top, okay, and I factorize it, I'm left with 2x minus 3 into 4x squared plus 6x plus 9, okay, divided by, oh, look at this, 4x squared plus 6x plus 9. The same expression, so these two cancel out, right? So to find the derivative of 2x minus 3, what are we going to have? We're simply going to have this equal to 2. Okay, right, and that is how the cookie crumbles, and we would have earned ourselves 15 marks out of that. Okay, so we are going to go on to the next question, which is question number 4. Question 4, right? They say a pentagon is created using candles as shown in the diagram. They say by adding more candles, a row of pentagons is formed, right? And continuing to add candles, a row of 3 pentagons can be formed. All right, so first of all, I want you to note, so this pentagon is formed. Firstly, they had 5 candles, 1, 2, 3, 4, and 5, right? But to form the second row, right, we took the first candles, 5 candles, and we added 4 more candles. Can you see that? And to make another row, you keep adding 4 more candles. Of course, this kind of makes, well, not kind of, it actually makes an arithmetic pattern, right? So what we are going to do, ladies and gents, is we're going to say, right, so we know this is an arithmetic pattern, right? So they say if this pattern continues, what is the maximum number of pentagons that can be formed in a row if a total of 100 candles are available? Right, so please, ladies and gents, I want you to note, so this would be term 1, this would be term 2, this would be term 3, right? So we want to know how many term numbers can we create if we've got 100 candles. And please note that the pattern is actually made out of candles. So our A value is 5. We started with 5 candles. And every time to make another pattern or another term, we are adding 4 candles, right? So we've got 100 candles in total. So Tn is equal to A plus n minus 1 times D, right? We've got 100 candles in total. We started with 5. This is 4, this is n minus 1 times 4, right? And so we're going to solve for n in this case. All right, so we're going to say, right, this is going to be, that's going to be 95, right? If we say 4n minus 4, right? If we take that 4 to the other side, that becomes 99, okay? And is equal to 4n. If we divide by 4 on both sides, right? So that's 99 divided by 4. Okay, so that's 99 divided by 4. We get 24.75, right? 24, n is 24.75. So really, what's the maximum number of pentagons that we can make? Now remember, 0.75 is not a full candle, right? So in this case, it's not a full number. So which means the maximum that we can actually create would actually be 24. So therefore, the number of pentagons that we can create are 24. Okay, right. So let's say n is 24 pentagons. All right. Okay, so please don't round it off to the nearest, because that means we cannot form a full pentagon there, right? So which means we'll only be able to create 24. All right, the next question, they say an arithmetic series has a first term 3, a last term 47, and the sum of all the terms is 300. Now remember, when we've got an arithmetic series, a first term and a last term, we're going to use the formula Sn is equals to Sn over 2 a plus the last term, right? So in this case, they said the sum is 300, okay, and n over 2. Our first term is 3 and the last term is 47. Okay, so in this case, what do we have? 3 plus 47 gives us 50. So n over 2 times 50 is equal to 300. Okay, so what I'm going to do there, right? So n over 2 times 50, this is going to give us 25n, which is equal to 300, and we're going to divide both sides by 25. Okay, all right, and I think that will give us 8. So that's 300 divided by 25. Well, actually, that's 12. Yeah, so my calculation, mental calculation was incorrect. So that's 12. So that means that that's the number of terms. Okay, Right, and they say determine the common difference, right? So remember, what do you have in this case? You've got the sum of all the terms, right? So I'm going to say Sn is equal to a, n over 2 rather, n over 2 into 2a plus n minus 1 d, right? So we know our sum is 300. Now we know that it's 12 terms that made 300. So I'm going to say 12 over 2. That's 2 times our a value is 3, right? And our n value is 12. 12 minus 1 is 11 times d, right? Okay, so let's try and simplify this as quickly as we possibly can. So this is going to be 6, okay, into, that's 2 times 3 is 6 plus 11d, okay. So divide both sides by 6. Okay, so let's do this. Okay, so I'm going to say 300 divided by 6. That will give me 50. So that's 50 is 6 plus 11d, right? So if I take the 6 to the other side, I've got 56, right, is equal to 11d. And if I divide both sides by 11, so d would be equal to 56 over 11. Okay, I'm going to actually leave it in that fraction form, 56 over 11. All right, and that is my common difference. Okay, right, so we go on to the next one. Now they're giving us a geometric sequence there, right? So they're saying we've got the sum of n, so that's the sigma notation, right? N is equal to 2 to infinity. So what we're going to have to do, ladies and gents, is first find out what is our a value. So we start from n is equals to 2. So this is going to be 4 into 1 over 2. And we've got n is 2 plus 2, right? So you've got 4 times 1 over 2. So this is going to be equal to 4 into 1 over 2 exponent 4, right? Please, ladies and gents, I want you to note in this case that's 1 over 2 to the exponent 4 is 1 over 16. So this is 4 times 1 over 16, right? Now, in this case, ladies and gents, I want you to note if I did this for the first 3 terms, so I'd have to do it for the first 3 terms, but I can already see that I'm going to increment n by 1 every time, so which means that my common difference, or rather my common ratio, will be 1 over 2, right? So my a value, 4 over 16, that's 1 over 4, right? So this is our a value, and our r is 1 over 2, right? So I'm looking for the sum to infinity, right? So I'm going to say, well, Sn, rather S infinity, okay, that's equal to a over 1 minus r. So our a value is 1 over 4 divided by 1 minus 1 over 2. Okay, right, so this is the same as saying 1 over 4 divided by 1 over 2. Okay, and you would note this would actually be the same as saying 1 over 4 multiplied by 2 over 1, right? So this is 1 over 4 multiplied by 2 over 1, and so that gives us 1 over 2. All right, so that is what we get. Right, and finally, they say in a geometric sequence, the third term is 5p plus 1, the fifth term is 4, and the seventh term is 1. Determine the value of p. So we know that the third term, so t3, right, would be equal to 5p plus 1. And they said that the fifth term is 4. So T5 is equal to 4 and T7 is 1. All right, so what I'm going to do, ladies and gents, let's try and find what the value of A and R is respectively. So T5, remember, for a geometric sequence, AN, TN is ARN minus 1, right? So, which means T5 is going to be A times R, right? That's 5 minus 1, which is 4. So AR to the 4 is equal to 4. And T7, again, that's AR6 is equal to 1. Right, so let's call this equation 1 and let's call this equation 2, right? And what are we going to do? Let's take T5 divided by T7, okay? So I've got AR4. In fact, yeah, just to make it easier, let's take T7 over T5. Okay, so equation 1 over equation 2. So that's AR6 over AR4, right? So you'd see that cancels out. So this would be equal to 1 over 4, right? Okay, so in this case, we've got, it means that R squared, okay, would be equal to, we're taking R6 divided by R4, that gives us R2, R squared, that's equal to 1 over 4. And so in this case, it means that the common ratio would be equal to 1 over 2. Okay, so we get 1 over 2 plus or minus 1 over 2. Okay, now note, ladies and gents, we're looking for the value of P. So we now need to get the value of A, so we can substitute that R value there, right, onto that equation, right, onto any of the two equations, right. I'm going to take substitute R plus or minus 1 over 2, right, into equation, I'm going to take the first equation, T5, right? So we know that AR4 is equal to 4, right? So A times 1 over 2 to the exponent 4 is equal to 4. So let's see what we get for the value of A. Okay, so we get, this is going to be 1 over 16, okay, is equal to 4. So the A value would be equal to, okay, so that's multiplied by 1 over 16 on either side, rather 16 over 1, okay, 16 over 1, that's 16 over 1 as well. So our A value would be 4 times 16, and that gives us 64. Okay, now that we've got the A value, remember we're given term 3, right? And in this case, they said for our term 3, we've got 5p plus 1, but we know this is AR, right? 3 minus 1, that's 2. So AR squared is equal to 5p plus 1. Sorry, I don't have enough space, ladies and gents. Right, so T, in this case, our A value, that's 64 into 1 over 2. Remember, that's our R value, right? And this is equal to 5p plus 1. Now, you could have chosen the minus. In this case, that would have given you negative 64. Either way, you would end up at the same point. Right, so in this case, to get the value of P, we're going to say 64 times 1 over 2 so that should be squared. Okay, so this is 64 times 1 over 4, right? Is equals to 5p plus 1. And of course, to try and get to the answer of this, that's 64 divided by 4, that will be 16, okay, is equals to 5p plus 1. If we take this to the other side, we've got minus 1, that would give us 15. So 15 is equal to 5p, and if we divide by 5 on either side, therefore p is equal to 3. Right. That is how we would go about that question. Of course, if you took r as negative, right, you would have gotten that answer to be negative as well. But either way, you would have actually gotten to the same answer. All right, so that is how this cookie crumbles. We're going to be moving on to the next question. For this next one, they say to us we should determine the common difference. Now remember that n was equal to 12 and we got the sum to be equal to 300. So now we're going to use the other formula for sum. So Sn, this is going to be n over 2 into 2a plus n minus 1 times d, right? So we know that the sum was 300. Okay, so we know this is going to be 12. This is the sum of the first 12 terms, isn't it? Right, so this is going to be 2 times, our a value was 3, and n is 12, so that's 12 minus 1, which is going to be 11, multiplied by d. Right, so let's try and solve this. So we've got 6, right, 300, and this is 6 plus 11d inside the bracket. So I'm going to divide both sides by 6, and that gives us 50. Okay, that and that cancel. So this is equal to 6 plus 11d. And if we take this to the other side, so 50 minus 6 will give us 44, is equal to 11d. And in this case, if I divide by 11 on either side, d will be equal to 4. Okay, and another way that we could have actually solved this was to use Tn, and T12 in this case would be a plus 11d, right? We were given the 12th term, right? The last term was 47. So this would be 47 is equal to 3 plus 11 times d, right? So that if we take the 3 to the other side, 47 minus 3 gives us 44, is equal to 11d. In fact, this was much simpler. Divide by 11 and we get d is equal to 4. Right, and so that is how the cookie crumbles as we move on to the next part. 5, so they give us the table below that shows the number of passengers that were on a bus after every stop, right? So we can see that the number of passengers is increasing. That's 2 to 20 to 34 to 44, right? They say the number of passengers on the bus after the nth stop, right? Bus stop can be given by Tn, all right? So that quadratic pattern there, right? So they say to us, write down the number of passengers on the bus after the 5th stop. So all we need to do, ladies and gents, let's see. So which means what is our first difference of this pattern? So you see, right, our first difference will be 20 minus 2, that will be 18, right? And the next one will be 34 minus 20, okay, so that will be 14, okay? And the next one, 44 minus 34, that gives us 10, okay? So can you see that the first difference keeps decreasing by 4, so which means the next value will be 6, and so in this case 44 plus 6, that will give us 50. Okay, right? So which means that the number of passengers that will be there will be 50 passengers. Okay, right, and then they say determine the value of A, B, and C. Right, so now we've determined what our first difference is. Okay, what is our second difference? So you can see we've got 14 minus 18. That will give us -4, right? And our first 10 minus, that keeps on decreasing by 4. Okay, so that's our second difference. So what do we do for a quadratic sequence? All we simply say is 2a, right? That will be equal to the value of our second difference. So our 2a is going to be equal to, so a will be equal to -2, right? And then to get b, we say 3a plus b will give us the value of the first difference. So 3a plus b gives us 18, but we already know that a is -2, right? Plus b, this will equal to 18. So the value of b will be equal to, now if I take the -6, 3 times 2 is -6, over to the other side, that will give me 24, okay? And to get the c value, we say a plus b plus c gives us our first term, and our first term was 2. So in this case, so the first term of the sequence, there it is over there, that's 2. So in this case, we've got -2 plus 24 plus c, and this should be equal to 2. Okay, so if we take 24 minus 2, that gives us 22. If we take it over to the other side, right, 22, so that will be 2 minus 22, and we'll get -20. So that is the value of A, B, and C respectively. Right, now, and they've given it to us there, just in case you didn't get it. So they say if it is given that Tn is -2n squared plus 24 minus 20, right, determine the maximum number of passengers on the bus. Right, now how do we get the maximum number in this case? So please remember, this is a quadratic sequence, isn't it? Okay, so this follows a quadratic expression, okay? So when do we get to the maximum point, right? When do we get to the maximum point? So in this case, the n value will be minus b. I would be incorrect there. So firstly, this is minus b over 2a, right? So this is when n is equal to minus b over 2a. So we know this is going to be at minus, our b value is 24 divided by 2 times our a value is -2. So in this case, this will happen okay, so this is 24 divided by 4. That will give us 6, right? So this will be at the 6th stop, okay? Right, but we want the maximum number of passengers, so we're going to say T6, that's -2 times 6 squared plus 24 times 6 minus 20. And in this case, let's try to get that. So that's -2 into 6 squared plus 24 times 6 and minus 20. Okay, and I get a maximum number. Okay, so it will be, the maximum number of passengers will be 52 passengers. Okay, right, so that means after that, the number of passengers would actually decline, right? So in this case, they say explain why the formula given in question 5C does not work after the 11th stop. Right, so if you think about a a quadratic, or in this case a parabola. So what we don't want is for the value of Tn to be negative. You cannot have a negative number of passengers. So let's see. In this case, if we factorize that and made it equal to 0, so we've got minus 2n squared plus 24n minus 20, right? So if we divide by negative 2, we're left with n squared minus 12n, right, plus 10, and this is equal to 0. Okay, so in this case, what are we going to have? Factors of 10 such that when I add them would give me 12. Okay, is that even possible? Right, so 5 and 2, no, doesn't. Okay, so let's just try and perhaps use the quadratic sequence, or rather our quadratic. In fact, why don't we just substitute n is equal to 11 there, right? Yeah, in fact, let's do exactly that. Okay, let's say T11, all right, instead of me doing all of that. T11, that's minus 2 times 11 squared plus 24 times 11 minus 20. Okay, let's do that quickly. So I'm just going to substitute 11 there on my equation. Okay, right, so at t is equals to 11, I end up with 2 passengers. But beyond that, I want you guys to note that's the first number of passengers that I started having. So which means that after 11, we will actually have negative number, right? So look at this. I'm going to convert that to 12 on my calculator. Okay. So if we make it 12, right? So which means in this case, after the 11th stop, you can't actually have a negative number of passengers. Okay, right. So I will say the number of passengers has to be a natural number. Okay, a natural number. Okay, right, so number of passengers has to be a natural number. So at t is equals to 12, we got a value of negative 20, which is impossible. You cannot have negative 20 people. All right, and we are going to leave it there, ladies and gents. All right, and that is really how the cookie crumbles. Let's go on to the next questions. Question 6, they say in the diagram below, we've got the graphs of f of x, which is equal to the square root of kx, and g of x, which is the log of base a, and x, and these are given. So they say note O represents the origin, right? Now, we're given those two graphs, which is f and g. They say the graphs of f and g intersect at the point 3 and 1. So I'm going to label that point, right? I think it would be nice if we did that. So we know that this point here would be where x is 3 and y is 1. Now they say to us, determine the values of x for which, the values of x represented on the sketch for which f of x is greater than g of x. Now, what do we mean when we say f of x is greater than g of x? So it means the one graph literally is above the other, right? So the y values of f are greater than the y values of g. Now you notice my f graph is this one, okay? And so where is that graph above the graph of g? So definitely here, right? Between 0, right, and 3, right? Okay, so in this case, it would be where x is an element of 0 to 3. Now notice they only said greater than, so 0 would definitely be included because definitely that graph is greater there. And in this case, 3 would be excluded because those two are actually, remember, they are equal at that point. Or you can say that x is greater or equal to 0 and x is less than 3. Right, I hope that makes sense, ladies and gents. Right, now they say to us, determine the values of k and a. Right, so we've got at least one set of values there, right? So remember, f of x is kx, right? Square root of kx. So f of x is equal to square root of k of x, right? Now I know this graph, in this case, when f of x, so f of 3 would be equal to 1. So I'm going to substitute that point there, right? That means that in this case, when I substitute square root of k, we don't know what k is, 3, this would be equal to 1. Now to solve this, all we need to do, ladies and gents, is just to square both sides, isn't it? Right, so what do I get? I get 3k is equal to 1. So k is 1 over 3. Right, and then we go to the graph of g of x. Okay, this is a logarithm graph. So g of x is log base a of x. All right, so for the log, we've got g of x is equal to log base a of x. But again, the graph of g of x, I know that when x, right, so g of 3 is also equal to 1. So that means that wherever I have x, I'll put in a 3 there. So the log of base a of 3 is equal to 1. Now, ladies and gents, I want you to please remember how to convert from logs, right, to exponents. So this base will become the base of your exponent, okay? And the solution or the answer here becomes the exponent, right? So this will be, it means that a to the exponent 1 is equal to the index, which is 3. So that means a is simply equal to 3. So that's how we get the value of a. Right, so now they say determine the inverse of f in the form y is equal to and state its domain, right? So we are simply going to take the graph of f. So we know that f of x is equal to the square root of 1 over 3 x. Now you remember that we got k to be 1 over 3, right? So now how do we get the graph of the inverse, right? So this is the same as just writing it this way. Y is equal to that. Now all we need to do to get the inverse, so this is f, right? So to get the inverse, we are going to swap the x and the y. So this is going to be the square root. Okay, let me write that nicely. This is going to be the square root of 1 over 3 y. So now all we need to do is square both sides, okay? Right, to try and get rid of that. So we've got x squared is equal to, now remember the square will cancel out the square root. So this is going to be 1 over 3y. And in this case, I'm going to multiply by 3 on either side. So what I do on the left, I do on the right. Okay, so y is equal to 3x squared. Now, please, I want you to note, okay, so if you look at the domain of f, right, where's our graph? Now, to find the domain of f, we would actually look at the range of the original graph, or rather, to find the domain of the inverse, we would look at the range of the original graph. So if you look at the range, this graph goes from y is 0. Can you see we start from 0, right? And it goes all the way, it will keep increasing up until infinity. And of course, if we were to draw the inverse of this graph, it would look this way, right? So the domain will actually be from 0, right, all the way up until infinity, because it keeps increasing as x increases, right? So our domain in this case will be x. So for the domain, I'll say x is an element of 0, right? And that's included because the graph exists there, right, all the way till infinity. But remember, you are excluding that, or you can simply say x is greater or equal to 0. Okay, right, and that is how the cookie crumbles, ladies and gents. Right, so they say to us on the next question, question 7, they say sketch the graphs of f of x is 3 to the exponent x plus 1, and g of x is 3 to the 2x. They say sketch the graphs of f of x. Now, what we're going to do is we're going to say f of x, right, which is equal to 3 to the x plus 1. Now, they did say we need to show the asymptotes, the intercepts, right, and the axes, with the axes and points of intersection, right? Okay, so in this case, we need to show those. Now, we know for the exponential graph, okay, so we need to make sure that we get that correct. We know that our asymptote is going to be at x is equal to 0, right? Or rather, y is equal to 0, I should say. So we're going to say, right, first of all, let's find the intercept. So when f is 0, I'm starting with f of x. We're going to do g of x on the other side. So this is going to be 3 of 0 plus 1. So what is that? We're going to have 3. So we know that when x is 0, y is 3, right? Now, usually at 0 we'd get 1. But let's look at what will happen if x is negative 1. Okay, so we'll have 3 negative 1 plus 1. That would be equal to 0. That would give us 3 to the power 0, which is equal to 1. So we'd know at negative 1 we'd have 1, right? And then I would also have when x is 1, what would be the value? Okay, so that will be x is 1. 1 plus 1, that gives us 2. So 3 squared, that would give us 9. So these are the points that I'm going to follow, right? Okay, so let's look at the other graph. G of x, I've got 3 to the exponent 2x. Right, so I'm going to do exactly the same points. When x is 0, right, you can see clearly when x is 0 there, so that will be 2 times 0, and so that will give us 1, right? So 2 times 0 is 0, so we'd have 3 to the exponent 0, and in this case that gives us 1. Okay, at minus 1, what do we get? We will get 3 to the 2 times minus 1 is negative 2. Okay, so that gives us 1 over 9. So that becomes 1 over 9. And let's see, when we have positive 1, so if we make x to be positive 1, that gives us 3 squared. 3 squared, which is equal to 9. Oh, and look at this. We've got this point here. So this must be the point of intersection between the two graphs, right? And we could verify this by simply saying, where is f of x equal to g of x, right? Where are the two graphs equal to each other? Okay, so I'm going to say 3x plus 1. Well, g of x is actually 2x. Before you guys accuse me. 2x, that's 3x plus 1. And so the bases are the same. I can drop the exponents. So 2x is equal to x plus 1, right? And if I take the x to the other side, 2x minus x will give me x, and x is therefore equal to 1. And please, I want you to note, guys, we get that the point of intersection is there, and it does verify it over there, right? Now, let's try and plot the points for f of x. I said when x is minus 1, I'm going to draw f of x with blue. Minus 1, I am going to get 1. Okay, and we said when x is 0, all right, so look at the grid that's given to me there, 1, 2, 3. Okay, when x is 0, we said y is 3. Okay, and when x is 1, we said y is 9. Okay, 9 is over there. Okay, I can see that my graph is increasing. And so if I look at that, when x is 2, actually, it will be minus 1 over... Okay, so it will be somewhere there. All right, so my graph, of course, it gets smaller. Then it starts increasing there until it becomes 9. So that's my squiggly graph there. All right, I couldn't really get it to be nice. Okay, so this is what my f of x graph would look like. And then let's draw g of x. I'm going to draw this in red. Okay, so let's find the points. We said it's got 0 and 1. So 0 and 1, this is it there. And at negative 1, we said it's 1 over 9. It's going to be this point here. And let's see. And at 1, the graph is equal to 9, just like this one. Okay, so for that graph, right, it will probably sit at the bottom there. And I mean, its rate of increase. Okay, let me just draw it nicely there. Its rate of increase would be actually steeper. Sorry about that. Would be steeper than the one for f of x. Okay, so this would be f of x in blue. Okay, I seem to be making a mess there. All right, I'm trying to replace those again. Right, so f of x in blue, right, and g of x in red. Okay, so I hope that you've got that. And of course, we need to label them. And they said we need to show this clearly, right? So this point here would be 1 and 9. Okay, and this point here would be 0 and 3. This point here would be 0 and 1. Okay, and of course we know that our asymptotes will be the line y is equal to 0. So in this case, our x-axis act as our asymptotes in that case. Right, and please show on your graphs. So this graph, the blue one, we said this is the graph of f of x. And the red graph would be the graph of g of x. Okay, So that is how the cookie crumbles, right? So that's what the graphs would look like. Okay, there's no point in us getting to know the other values because, I mean, they would be so high, and when you go to the negative, that'd be extremely low. Right, and then in the next one, they say to us, rewrite the equation a to the 2x equal to 3x plus 1 in the form x is equal to. All right, now what we're going to do here is, so we've got a to the 2x equal to 3x plus 1. Now there's no way that you can drop the exponents and so on, right? So what we're going to have to do is introduce logs, right? So I'm going to say, right, let's introduce the log. Okay, this thing can be frustrating at times. The log of a to x is equal to the log of base 3 x plus 1. And we know the rule of logs, right, is that we can take the powers or the exponents and we can jump them down. So that's x plus 1, right? Log of 3 is equal to 2x, the log of a. Now, let me try and get my expressions with x only. But firstly, let's multiply through this one. Do a FOIL method. So I'll have x log of 3 plus log of 3. This is equal to 2x log of a. Right, so I've got two values or two expressions there with x. So I've got 2x log a minus x log of 3 is equal to log 3, right? So if I take out x as a common factor, so I've got 2 log a minus log 3, which is equal to log 3. Now, ladies and gents, all I'm simply going to do is divide both sides by 2 log a minus log 3. What I do at the bottom, on the left, I do on the right. So this would be 2 log of a minus log of 3. Right, so in this case, if we've got x, so that cancels with that. So x would be equal to log 3, right, divided by 2 log a minus log of 3. Right, and that is how I express the value of x. All right, and that is how this cookie crumbles. Would have earned ourselves 9 marks. All right, and I hope that you guys understand. Now on to question 8. Right, so they say to us, explain why the equation 2x minus 1 all squared is equal to negative 5 does not have any real solution. Now, when I look at this, if you look at the expression 2x minus 1, okay, let me just get my pen to work, right? So if you look at that expression 2x minus 1 all squared, remember, it can never give you a negative number. Whenever you square something, you can never get a negative solution because this expression will always be greater or equal to 0. Okay, right. So on to number 2, they say to us, on a set of x's, sketch the graph y is equal to 2x minus 1 all squared plus 5. I'm sure you can see why they were asking us that. So we already know that we won't have any x-intercepts, right? So what I'm going to do, now I know that many people would make the mistake to think that those are the coordinates of the turning point, right? Remember, in that case, it would have been the case if we had only x inside the bracket. But what we need to do now is to multiply that thing out and get 4x squared, right? So I'm multiplying that bracket out. So this is for the middle term. You'll say 2x times negative 1. That's negative 2x times 2. So that gives me minus 4x plus 1 plus that 5 that's outside, right? So y is equal to 4x squared minus 4x plus 6. All right, so first of all, I know that already my y-intercept, okay, this is going to be at 0. So this is where x is equal to 0. Okay, if I substitute for 0 there, my corresponding y value is 6. Okay, and I know I won't have any x-intercepts in this case. Right, so what I'm going to do is find the value of the turning point. Okay, so x value of the turning point, that's minus b over 2a. That's minus our b value is 4, negative 4, divided by 2 times positive 4 there. Right, so what am I going to get? 4 over 8, so which is going to be 1 over 2. Okay, so if you substitute that into the equation, so the y value of your turning point will be 4 into 1 over 2 squared minus 4 times 1 over 2, and this is plus 6. Okay, let's see what we get there. All right, so I'm going to have 4 times 1 over 2 all squared. Okay, so that's squared. Minus 4 into 1 over 2, right, and plus 6. Okay, I get a value of 5. Okay, right, so I get 5, so I know my turning point will be at 1 over 2 and 5. All right, now you can try and get all the other values, so I'm going to go there. Let's first of all identify a turning point. We said, okay, so these are incrementing. So that's 2, 4, 6, 8, and 10. Right, so we want 1 over 2 and 5. So 5 would be over there. Okay, so that's our turning point. And note the a value is positive, and our graph is passing through 6. Right, so that's my turning point. Okay, well, maybe I can get the negative 1 value. Okay, let me see. When I substitute for negative 1 over there, so if I say x is negative 1, so that's negative 3 inside the bracket, all squared, that's 9. 9 plus 5 is 14. Okay, so at negative 1, I'll have 14. Okay, so that means that will be the same at 2 as well. All right, so my parabola looks something like this. Okay, and it will just keep going, right? Okay, so that's what our parabola looks like. Okay, so let's try and, okay, apologies for this message that keeps popping up. Okay, I'm using a PDF, so it keeps saving every time I am editing it. So they say draw how you would shift the graph vertically so that the y-intercept are real, the x-intercepts rather, are real and equal. Now remember, when roots are real and equal, that means that the turning point would be sitting exactly. Oh, now I needed to label the turning point. We said that's 1 over 2 and 5, right? That's our turning point over there. Now, what would I need to do for the turning point to be sitting exactly on the x-intercept, right? So I would need to shift the graph vertically downwards by 5, isn't it? So they said describe it. So I'd shift the graph down by 5 units. Okay. What we mean by equal roots is that in this case it has only one x-intercept, and that's when the x-intercept is the turning point as well. Okay, so let's go to the next one. They say solve for x in terms of k, all right, if 2x minus 1 all squared is equal to k, and write down the values of k for which the equation has real roots. Now, they said solve for x in terms of k, right? So, which means we're going to say 2x. Okay, we've already done this. So, that's 4x squared minus 4x, okay, plus 1. Okay, let me write this nicely. So, that's 4x plus 1. So, I'm going to bring the k over to the other side. So, that's minus k, which is equal to 0. Now, they said solve for x in terms of k. So remember, we're going to say, right, x is equal to minus b plus minus the square root of delta, which is b squared minus 4ac, okay, divided by 2 times a. Now, I'm just simply going to substitute there. Right, so that's minus our b value is negative 4. So that's negative 4 minus a negative 4 plus minus the square root of, right, so if I see there, I've got negative 4 all squared minus 4 times a is 4 and c is 1 minus k. So it's that entire constant there divided by 2 times 4. All right, so let me just write out. So that's going to be 4 plus minus the square root of, now I've got 16 minus, now if I say negative 4 times 4, that gives me minus 16 times 1. That's minus 16. Okay, plus, so negative 16 times positive k. That's plus 16k. All right. And all of this is over 8. Okay, so these cancel out. So I actually end up with 4 plus minus the square root of 16k divided by 8. All right, so that's what we get for our final answer. Right, so that will be x in terms of k. Right, now they say to us, give 3 values of k for which the x-intercept of y is equal to that entire thing plus k. Right, now, please, ladies and gents, I want you to note will be real, rational, and unequal, right? Now, we've taken that entire thing, which in this case we said this is y is equals to 4x squared plus minus rather 4x. Now, in this case, it's going to be plus 1 plus the k, right? So that's plus the k, right? Now, in this case, remember, what we need to work out for nature of roots is the value of delta. So delta is b squared minus 4ac. So I'm going to take my b squared, which is minus 4 squared, minus, that's 4 times our a value is 4, times c, which is 1 plus k, right? So this is 16. Again, this is minus 16. But this time you've got minus 16k, right? Those two cancel. So our delta value is minus 16k. Now remember, for real roots, delta has to be greater than 0. For rational roots, it has to be a perfect square, right? unequal, well, it just simply means that it has to be greater than 0. For real, you can have greater than or equal to 0, right? But in this case, for them to be really unequal, they definitely have to be greater than 0, so which means delta cannot be 0, right? So in this case, we want rational roots. So we want this expression to be a perfect square. Now, it can only be a perfect square in this case. Let's see, if we substitute k for -1, yeah, if we make k -1, right, definitely that will be positive 16. That's a perfect square. Or k, we can't substitute k is equal to 0 because we did say that delta cannot be equal to 0. Another one is when k is, shall we say, -1/4, right? 4, that would give us 4. So it can be -1/4. So that will give us 4. How can we make it 1 as well? Or k is -1/16, right? Because when we substitute -1/16, k therefore would be equal to 1, which also is a perfect square that's greater than 0. All right, I hope that makes sense, guys. Right, and for the next portion, okay, they say let the larger root of px squared plus qx plus r equal to 0 be p, and let the larger root of the other expression x squared plus qx plus pr equal to 0 be q. All right, so let's work out the value of p. Okay, so that's going to be minus b. So our b value is q. So that's minus q plus minus the square root of b squared, right? So that will be q squared minus 4 times our a is p and our c is r, divided by 2 times p, 2a. So that's 2p. Right, and they said the larger root of it. So the larger root is when I don't have the plus or minus. So in this case, this is when I just simply have the plus, right? That will be the larger root. So they said let that be p, okay? Big P, that is. And the larger root of the other expression, so q, will be equal to, again, let's do the same thing. So this will be minus q, okay, plus minus. So I'm just simply going to take the positive one, okay, because that's the larger root. So this will be the square root of, so that will be the square root of, let's see, this is q squared, again, minus 4. Our a value is 1, okay. Our c value is pr. So this will be 4pr. Okay, so it looks exactly the same as the other one. So that will be pr divided by 2 times, so this is 2 times 1. Okay, right, our a value is 1. All right, now they want the ratio. So remember, how we can also do the ratio is that we can say p divided by q. I'm going to do this. I'm going to say, I can see it's already going to cancel, right? So p is minus q plus the square root of q squared minus 4pr, right, over 2p divided by, now remember, for division, I can actually say, okay, so let me just divide it. So this is going to be minus q plus square root of 4 q squared minus 4pr. This is divided by 2. Okay, so remember that I can actually change division to multiplication, but I need to invert that entire expression. So I'm going to say, right, I'm doing this to save a little bit of space. So this is going to be 2. So I invert that entire expression. That's minus q plus the square root of q squared minus 4pr. Now notice what's going to happen in this expression. That entire thing at the top is going to cancel that at the bottom. So this and that cancel. So I'm left with, okay, 2 and 2 cancel. So I'm left with the 1 at the top. So that means the ratio of P to Q will be 1 over small p. So P to Q will actually equal to 1 is to P. I hope that makes sense, ladies and gents. And with that said, we are done with that question. Okay, so we can move on to the next question, which is question 9 on cubic functions. So they say in the diagram below, the graph of f of x, which is ax cubed plus bx squared plus cx plus d, and gx, which is 2 over x plus p plus q, are given. All right, now they say E is the point of intersection, okay, of the graph of f and g. So that's that point over there. And they say to us f is the point of inflection. All right, now they say the graph of f cuts the x-axis at x is 1 over 2 and touches x equal to minus 3 and cuts the y-axis at 9. All right. Now they say to us, show that the value of A is equals to minus 2, B is negative 11, C negative 12, and D. Now, ladies and gents, what I'm going to do here is that I'm already given the turning point over there, right, which is also the x-intercept, as well as one of my x-intercepts, right? So which means if I were to work out the value of this graph, now please, I want you to note, I'm going to actually take all my x-intercepts, right? So that's going to be x minus 1 over 2. But now, when the x-intercept is also the turning point, so then that would be, so remember to change the sign, so that would be x plus 3. So when it is that turning point, you actually square that. Okay, so I'm going to multiply that out. So I'm going to say, right, in fact, before I even go far, let's do this. Let's find out what the value of A is. So I'm going to use another point. And remember, the y-intercept, okay, is 9. So when x is 0, y is 9. So y is 9 when x rather is 0. So that would be minus 1 over 2 times 3. Okay, so 3 squared. Okay, so A would be equal to negative 1 over 2 times 3 squared is 9. So I get minus 9 over 2, and this would be equal to 9. Okay, so if I divide both sides by negative 9 over 2, that's negative 9 over 2, and that cancels with that. I will get, right, so if you do that, so that will be, so this will be equal to negative 2, right? So A will be negative 2. All right, so remember, this is the same as multiplying by 2 over 9, negative 2 over 9. And what you do at the bottom, you do at the top, negative 2 over 9. Okay, over 9, that 9 and that 9 cancel. Okay, that cancels with that, that cancels with that, and that's why you get a is -2. Right, so which means eventually we've got y is equals to -2 into x minus 1 over 2. And now what I'm going to do is just expand that bracket. So this is going to be x squared plus 6x plus 9. Okay? Right. So let's multiply all throughout. So that's -2. Okay, so what I have there, so I'm going to multiply that entire thing out. So x times x squared, that's going to be x cubed, right? So I'm going to take that times that, that's 6x squared, all right? X times 9, that would be plus 9x. Negative half times x squared, that's minus half x squared. And negative a half times 6 would be minus 3x. Okay, and negative half times 9, that would be minus 9 over 2. Okay, right. So let's try and sort out what's in here. Sorry, that was x cubed, not x squared. So that will be x cubed, right? So we've got 2x squared terms, 6 minus a half. That would give me 5.5, okay? So that would be 5.5. Okay, so that's minus 11, sorry, plus rather, 11 over 2 x squared. Okay, and we've got 9x minus 3x. That would give me 6x, right? So that would be plus 6x. And that would be minus 9 over 2. Okay, and we can multiply all throughout by that -2. And what do we get? Negative 2x cubed minus 11. 2 times 11 over 2 would give me minus 11x squared. 2 times 6 would be negative 12x. And 2 times 9 over 2 would give me 9. But in this case, a negative times a negative gives me a positive. And definitely, A is -2, B is -11, C is -12, and D is 9. And that is how the cookie crumbles. Right. Now they say determine the x-coordinate of f. So remember what f is. They said that's the point of inflection. So what we do, we're going to take f prime of x, right? Remember, for the point of inflection. In fact, I'm going to show you even another way of getting that point of inflection. That's the midpoint of your x values of your turning points, right? But what you can do traditionally, we say we take the double derivative and make it equal to 0. So that would be minus 6x squared. That's the derivative, right? So jump down and minus 1. Okay, so that's minus 6x squared minus 22. Okay, so that's minus 22x minus 12, right? Okay, and so for the double derivative and make it equal to 0, so that would be minus 12x minus 22, and this is equal to 0. Okay, minus 12x is equal to 22, and if I divide that by -12, okay, -12, so x would be equal to, all right, what is 22 over 12? That would be 11 over 6, isn't it? -11 over 6. But what I also wanted to show you, ladies and gents, is that for the x value of the point of inflection, all right, I can take the midpoint. Now remember, I knew what my my turning points are, or actually I don't know the other turning points, so actually I can't do that. All right, but please remember in future, if you know the x values of your turning point, you'd be able to get your point of inflection. So x is negative 11/6. They only wanted the x coordinate, so we're not going to worry ourselves about the y. Right, now they say if the gradient at point E of the graph of f of x is 8, determine the coordinate, the x coordinate of E. Now remember, to get the x coordinate, right? I mean the gradient of a graph, that's the derivative, right? So that means the derivative at E is equal to 8. But now how do we get the derivative? We're going to take minus 6x squared, right? Minus 22x, we said minus 12, right? This is equal to 8. So let's try and, so that's minus 6x squared minus 22x. Okay, if I bring the 8 over to the other side, that gives me minus 20, and this would be equal to 0. Okay, so if I can try to divide by, let's see, negative 2, I get 3x squared, okay, minus 11x, okay, actually plus, okay, because I divided by negative 2. So everything changes sign, and this is plus 10, and this is equal to 0, right? Okay, so let's try, are we able to factorize that? Let's see, factors of 3 and 10. Let's see if we say 5 and 2. Okay, such that when I add them, I get 11. Ah, there, I got them. 3 times 2 gives me 6, and 5 times 1 gives me 5. And if I add those, I definitely get 11. So that means this is my first bracket. That would be my second bracket. So in this case, I've got 3x plus 5 as well as x plus 2 is equal to 0. So x is negative 5/2, or x is equal to negative 2. Okay, right. But now we are looking for the x coordinates of E. If I look at E, in this case, this would be definitely before the other turning point. So I would tend to take the point after the point of inflection. All right, so that would be the smaller value. Okay, let's see. So that's minus 2 and minus 5. Sorry, that's 5/3, right? So this would definitely be the point after that point of inflection of ours. So I'd say E is definitely minus 2 point, minus 2 in that case. Remember, we are still not done. We still need to find the corresponding y value, right? I don't know why we've been given such little space. Right, so we've established that x will be negative 2, right? Because definitely this value is actually greater than our point of inflection, and we know that our that point E was actually less than the point of inflection. It's on the left hand side of that of that, right? So in this case, what is our corresponding y value? So we're going to substitute for 2 into the original equation. Okay, so let's do that. Okay, I'm going to go back to the original equation, right? Please help me out with that. So that's going to be negative 2 times 2 cubed, right, minus 11 times negative 2. Actually, that was supposed to be negative 2. Apologies. Times negative 2. Okay, so that's negative 2. And that's negative 2 squared. Right? That's minus 12 times negative 2 again. And that is plus 9. Okay, so I get the y value being equal to 5 there. Okay, so the point E, ladies and gents, would be negative 2 and 5. Okay, right, now they say if the graph of G has a vertical asymptote at the minimum stationary point of F, right, determine the equation G in the form y is equal to 2 over x plus p plus q. Now, they say to us the minimum asymptote, or rather, did they say the vertical? Yes, the vertical asymptote is at the minimum stationary point, right? So what was the other x-intercept? So remember, when we talk about the stationary point in this case, we are talking about this x-intercept. So they're saying to us the vertical asymptote would be here. So we know that when we write down for the vertical asymptote, this is the x-asymptote, right? So that's at minus 3. So let's write down that graph. So this is going to be y is equal to 2 over x. Now remember, we always change sign for the x. So this is x plus 3 plus q, right? Now we need to find the vertical asymptote, the horizontal rather asymptote. And how are we going to get that, right? So remember, we also have the point of intersection, right? Remember the two intersect in this case at E, which is negative 2 and 5. So what I'm going to do is I'm just going to substitute that point there. I know when x is equal to negative 2, y is equal to 5. So I'm going to say 5 is equal to 2 over, right, when x is negative 2 plus 3, okay, plus q. Right, so what does that give us? That gives me 2 divided by negative 2 plus 3 gives me 1. So 2 divided by 1 in that case, so that would be 2 plus q is equal to 5. So q would be equal to 5 minus 2 gives me 3. So it seems like the horizontal asymptote is at 3 as well. Okay, so somewhere over there. All right, so this is at y is equal to 3. Right, so what would be the final equation? So we've got simply y is equal to 2 over x plus 3 minus, x plus 3 plus 3 as well. All right, please remember that the y asymptote does not change sign. Right, now they say to us, determine the equation of the axis of symmetry of the graph of F, of the graph of G rather, that has a positive gradient. Now remember, ladies and gents, the hyperbola always has the axis of symmetry at the, now they want the positive gradient, it's going to be y is equals to x plus c1, right? So for the negative gradient, you are simply going to say x is equals to minus x plus c1, but they only want the positive gradient. Now, how do I get the value of c? In this case, I simply will take my asymptotes. Now, you remember that my asymptotes will be at negative 3 and 3. So that axis of symmetry passes through the intersection of my asymptotes, which is at minus 3 and 3. So I am simply going to say, right, when y is 3, x is negative 3, plus c1, taking the 3 to the other side, so c1 would be equal to 6. So that means that axis of symmetry in this case would be equal to x plus 6. All right, so the next question, they say to us, determine the values of x for which f of x is greater or equal to g of x in the interval x is an element of minus infinity to 0. So that means that will be on the left hand side of your y-axis, right? So that's where x is negative. Right, so we want where f of x is greater than g of x. All right, so on the negative side, where is f of x greater? Definitely, it would be greater over that section there up until 3. Remember now, this one starts going to the, that's at the asymptote. Okay, so that's excluded. But where else is it greater? Where is it above g of x? That would be between that section over there. So I would say this is between x is negative infinity, right, all the way up until 3, and from negative 2 till 0. So let's write down that solution. Okay, so I would say, well, this is where x is an element of negative infinity, and remember we never include infinity, to negative 3. Right, so I would not include that because of the asymptote. Okay, and then also at x is, okay, we said from, was that negative 2, right? Let's check there. Yeah, so from negative 2, that would be included because they are equal there. Okay, so from 2, negative 2, all the way up until 0, also included, because in that case, remember that they are still greater than each other. Right, so the next portion, they say determine the values of x if the graph of f is shifted so that the new graph of h of x is equal to h of x minus k rather is equal to that entire expression, does not intersect the graph of g, right, for x is greater than 0. So they're saying on the right hand side, on the positive x axis. Right, so h of x, what we need to check there is that will be equal to minus x cubed minus 11x squared minus 12x plus 9 plus k, right? So what have we done? So h of x is essentially f of x plus k. So we want to know how will we have to shift the graph of f, right, so that it does not intersect with the graph of g. So essentially that's what we are asking. Right, so let's go back to the graph. We're saying we're looking at the right hand side. Now they will only intersect. Now please, I want you to note, if I can, all right, what would be the y-intercept of that graph? Because if I can shift the graph of f downwards, okay, by the value, or in this case by the difference of their of their y-intercepts, right, they will not intersect on the right hand side. Okay, so let's find out what is the y-intercept of our hyperbola, right? So this is where x is equal to 0. So remember that was our hyperbola graph is 2 over, okay, so that would be 2 over x is 0. 0 plus 3 plus 3. Okay, so that would be 2 over 3. Okay, in fact, we can just multiply that for ourselves. So this is 3 times 3, that's 9 plus 2. So that simply will be 11 over 3, right? So in this case, what I'm going to say there is that, okay, so if we find out this is 11 over 3, so if we can shift the graph of f down by that value, okay, it will not intersect with the graph of g on the right hand side. Okay, so let's see what would be that value there. So that would be 9 minus 11 over 3. Okay, so if I say 9 minus 11 over 3, that gives me 16 over 3. Okay, right, so k would be any value that is so k would be negative, right? We're shifting it downwards by any value that is 16 over 3 and below. So k would be actually less than or equal to negative 16 over 3. Remember, in that k was positive here, but we are shifting down, so that's why we're saying negative, and it must be any value that is more than 16 over 3, but taking it down, and that's why we're saying less than, okay, 16 over 3, and that is what the value of k will be. All right, and now we go on to the next section, which is question 10. Right, so we're given there an oil tank, okay, tank structure as shown in the diagram consists of a cylindrical body of length h and right, and two hemispherical ends of radius r, okay, and has a volume of 1,000 cubic meters, right? They say determine the values of r such that the total surface area, okay, of the tank is a minimum. All right, now let's look for the volume first of that entire structure. So the volume would be the volume of the cylinder, okay, and plus the volume of the hemispheres on the left and the right hand side. And now, so the volume of the cylinder we're given there, right? So this is the volume of the cylinder, and the volume of a full sphere is 4 over 3 pi r cubed. Now remember, two hemispheres put together will give us an entire sphere, right? So in this case, the total volume will be equal to pi r squared h plus the volume of the hemisphere, two of them, right, give us a sphere. So this is pi r cubed. Okay, right, but we know this, they said, is equal to 1,000. So what I'm going to do is, because I just want that in terms of r, I'm going to take out h as a common factor. So this is going to be pi r squared h is equal to, this is 1,000. So it's 1,000 minus 4 over 3 pi r cubed, okay, and I'm going to divide by pi r squared, but what I do on the left I do on the right, so this is over pi r squared. So that would be my expression for h. Right, now remember, what I'm trying to minimize is the surface area, right? So the total surface area, okay, in terms of r will be, okay, so the surface area of a sphere, right? So, and I did say to you that a hemisphere plus a hemisphere will give us a full sphere. So that will be the surface area. Okay. And then the surface area of a cylinder. Now, please, I want you to note, ladies and gents, now the 2 pi r squared would be for a cylinder that is closed, right? So if you think about, a cylinder, if I've closed it on this side, so that's the area of a circle. And if it's also closed on the other side, that's another circle. So that's where the 2 pi r squared comes from. But in this case, we don't have this section because remember, it's closed by the hemisphere. So we only have this portion, which is just for the cylindrical part, okay, without the enclosures of the circles at the top and at the bottom. Okay, so we've got a surface area would be 2 pi r times h plus the cylinder, which is 4 pi r squared. All right, so what I'm going to do, let's try to get rid of that h there. Okay, remember we had 1000 minus 4 over 3 pi r cubed divided by pi r squared. Okay, right, so this was just the h plus this is 4 pi r squared. Okay, so what happens there? This pi will cancel with that one. This r squared cancels with that r. Okay, so I'll have, in this case, 2 times 1000, okay, over r. So this is going to be 2000 r minus 1, right? And then I'll have 2 multiplied by 4 over 3, right? So the r will cancel the cube and we'll be left with the square there. So this will be 2 times 4 over 3, which is 8 over 3. So that's minus 8 over 3. Okay, and why did I minus, by the way? Oh, yes, yeah, it is minus. So that's minus 8 over 3. Okay, that's going to be pi r squared, okay, plus 4 pi r squared. Now, in this case, to just simplify it a little bit further, we've got 2r minus 1. Okay, so that's 4 minus 8 over 3. That's 8 over 3. Okay, I get 4 over 3, right? So that's going to be 2000 r minus 1, r to the negative 1, plus 4 over 3 pi r squared. Right, so this is the surface area in terms of r. So I've eliminated all the variables. So now remember, what do we do to maximize? We're just simply going to take the derivative of this. So we're going to take surface area, the derivative of it, right? So that will give us minus 2000 r minus 2, okay? And we'll have 2 times 4 over 3. This is plus 8 over 3 pi r. Okay, and this is equal to 0. Right, so let's try to solve that. If we take the 2000 over the other side, so I'll have 8 over 3 pi r squared, pi r rather, is equal to 2000. Now please remember the r minus 2, I can simply say this is over r squared. Okay, right, so let's cross multiply. Okay, we've got quite some gymnastics to do there. Okay, so this will be 8 over 3 pi r cubed equal to 2000. Right, just to make it simpler for ourselves. So we'll divide by 8 over 3 pi. This is going to be 8 over 3 pi. Right, that cancels that entire thing. And we're going to take the cube root of that, right? So r, okay, I've run out of space. So r will be the cube root of that entire thing, which is 2000, okay, over 8 over 3 pi. All right, so let's do that on our calculator. So this is going to give me the cube root, okay, of 2000 over, okay, again, this is 8 over 3, sorry, this is 8 over 3 times the value of pi. All right, where is pi? Over there. Okay, I get a value of r is equal to 6.2. Please verify that for me, and that would be in meters, right? Because our volume, or rather our cylinder, the volume of our cylinder was in meters cubed, so it must mean that the dimension must be in meters. Right, as we go on to the next question. The last question, they say we've got 10 coins that are arranged in a row. They say 5 coins are 1 rand, 3 coins are 2 rand, and 2 are 5 rand coins. Right, how many different arrangements are possible, knowing that all the coins of the same value are identical? Now, in this case, ladies and gents, it means that we are considering the fact that identical coins, okay, we don't take them as being different, okay, in this case. So there's repetition that is involved, right? So if you've seen me do probability, you would know. So if we were not considering repetition, it simply would have been the probability of the arrangement, or rather, in this case, the number of arrangement would be just 10 factorial, which is 5 plus 3 plus 2, right? So it's 10 coins. So in this case, it would be 10 factorial. But if we consider, okay, repetition, so now we're going to look at all the numbers that are repeated. So 5 coins are repeated. So we're going to divide it by 5 factorial times 3 2 rand coins are repeated. So that's 3 factorial, and 2 of the 5 rand coins are repeated, 2 factorial. Okay, so let's see. So we're going to say 10 factorial there, divided by, okay, I'm going to say 5 factorial times 3 factorial times 2 factorial. Right, so the number of possible combinations that we can make is 2520. Okay, so the next portion, they say the trees in an orange orchard, okay, are harvested twice a year. During the first harvest, 70% of the oranges are picked, while the rest are left. At the second harvest, 35 of the remaining oranges are picked, while the rest are not picked. Assume no oranges were added between the harvests. Okay, right, now they say calculate the probability that a randomly selected orange will not be picked. Now, I think the best way to demonstrate this would be through a tree diagram, right? So I'll say, well, first of all, the probability of picking an orange, that's 0.7. Okay, that's 70%. So meaning that the probability of not picking would be 30%, right? So not picked would be 0.3, right? But of the ones that are not picked, okay, at the second harvest, the probability of picking them, so the probability of picking would now be 35%, so that's 0.35, meaning the probability of not picking in this case would actually be 0.65. Okay, so they want us to calculate the probability that a randomly selected orange will not be picked. So if it's not picked in the first harvest, nor is it picked in the second harvest. So the probability of that will be 0.3 times 0.65. So 0.3 times 0.65. Okay, so let's take that. 0.3 times 0.65. That gives me 0.195. So that's the probability that an orange will not be picked at all, right? Okay, I'm trying to write this nicely. Probability of not picking. Okay, right, so that is it, ladies and gents. Okay, let's go on to the next question. They say if it is further given that all oranges that are picked are packaged with 9% from each harvest selected for export and 31% sold to the local market, right? So the rest are sent to a factory to be made into juice. What percentage of oranges will be sent to the factory to be made into juice? Now, ladies and gents, I want you to note, first of all of those are the oranges that are picked. Okay, so those are the oranges that are picked. So in this case, I'll say the probability of picking oranges. Now remember, we had the probability of not picking, right? In this case, it was 0.15. So that a probability that an orange will be picked will be 1 minus the probability of not picking, okay, of not picking. So this will be 1 minus 0.195, okay. So that's 1 minus 0.195. So that's 0.805. So that's the probability of that an orange will be picked, right? And they said to us, so the rest will be made into juice. So 9 plus the 31, well, that's the 40%. That's going to be 40% will be converted or will be made into, will be exported and the other sold. But the rest, which is 60% now, so which means in this case the percentage of the ones that will be made into juice will be 0.805. So the ones that will be made into juice will be equal to 0.805 times 60%. Okay, that's 60%. And so what will be that percentage? 0.805 times 0.6. Okay, so that will be 48.3% will actually be made into juice. All right, and in this case, they say there are 120 oranges in the export box. Okay, and they say if 172 export boxes are produced, then how many oranges were in the total crop? Okay, so ladies and gents, I want you to note, remember that the export boxes, okay, so that's 120 times 172. Okay, let's get that. The number of oranges there. So 120 times 172. That's going to be 20,640. Okay, oranges, right? Now, please, I want you to note, they said to us the ones that were exported were only 9% of the total crop. Okay, so this is 9% of this. Okay, 0.8 of the ones that were picked. All right, so in actual fact, so that's 9% of that 0.805. Okay, so I am going to say, right, so it means 9% of the total, so that's 9% of the total, okay, times the total amount, okay, will be equal to, no, actually 9% of the 0.805, 0.805, okay, will actually amount to 20,640. Okay, so in this case, I want you to note this is of the total amount. Okay, so what I'm going to actually do is say, right, so I'm looking for the total amount in this case. So 0.80 multiplied by the total amount will give me that value. Okay, so 9%, that's going to be, so that's 0.9 times 0.805. No, sorry, 0.9 times 0.805. Okay, right, no, actually this is 0.09, not 0.9, because that's 9%. So in this case, that means that this, in terms of percentage, that's going to give me 7.2% of the total, right? If I multiply by 100, so this is 7.245 if you want to. Okay, of the total is going to give me 20,640. Okay, and this is 7 over, that's a percentage over 100. So let's try and do the mathematics, ladies and gents. So T will be equal to 20,640 divided by, okay, or multiplied by 100 divided by 7.245. Okay, right, so that's 20,640, okay, multiplied by 100, okay, and that's divided by 7.245. Okay, I get a total number of oranges to be 284,886. Now, the 0.12 of an orange I will not take. That's not a full orange. So that will be the total number of oranges that we had. I hope that makes sense, ladies and gents. All right, and that brings us to a total of 150 marks, and that is a wrap. Now, please don't forget to subscribe and like, and let me know if this is helping. Okay, otherwise, I will see you guys next time. Shap shap.